Hello everyone. Let's study about the principle of superposition of waves. To define this, it states that if two or more waves are made to overlap, then the resultant displacement at any instant of time is equal to the vector sum of the individual displacements produced by individual waves at that instant of time. To understand this, let's recall that the displacement of a wave is given as y is equal to a into sine kx minus omega t plus phi. Let's assume that phi is 0, so it becomes y is equal to a into sine of kx minus omega t. Let's take instance where we take waves of different frequencies and different amplitudes as given here. So we'll call this as k1 also, and this as sine of k2x minus omega into t. We're taking two waves here. Let's assume that the displacement what this can cause is say 3 meter and what this can cause is say 5 meter. To understand this, imagine that only the first wave propagates. Example, think that we have a medium here and the first wave is propagating. It means that the first wave can cause a displacement of up to 3 meter. Suppose if this is the origin and these are the particles in the medium, for example, think like a rope, then this wave can cause a displacement of up to 3 meter in both the directions. Means at some point of time, if this is like the wave propagating, it means that this wave can cause a displacement of 3 meter. Means this is called a snapshot. Snapshot means if you go and take a picture of the wave, this is what we get at some point of time. It means that the wave from here has gone to this position. The wave from here has gone to this position. The particle from here has gone to this position. The particle from here has gone to this position. And later what happens as time goes on, this will come down also, which means every particle, if this is a mean position and this is the plus 3 meter mark and this is minus 3 meter mark, then every particle will oscillate between the 2 points. It will oscillate between 2 points like this. It keeps on moving between 2 points like this. It does an oscillating motion between 2 points like this. That's what the 3 meter means. Apparently, the particle here is at the mean position. The particle from here has gone to the other extreme end. This is called as displacement. And for example, think of this distance. Think of this as 2 meter. The particle from here has gone up to 2 meter. Even here, it's up to 2 meter. So keep in mind that every particle will oscillate between the two mean positions. Instead of this case, think of a case where the other wave is propagating. Let's take a case where this is moving in the minus x direction. So the equation becomes sine of k2x plus omega t. Now this wave would cause a displacement of each particle up to 5 meters. Cause up to a 5 meter displacement. So at some point if you see the wave, it will be something of this kind. This would be its displacement. So this wave causes up to a displacement of 5 meter. So until here this would be 5 meter. Particle from here has gone to the maximum displacement. Similarly, particle from here has gone maximum in the other direction. It's gone till here. Now what happens a case where if both the waves together come, that is, there's one wave coming from this side and one more coming from this side. If you want to look at any particle, if you want to look at this particle alone and see what happens, then what happens is if this crest falls on this crest, that is when they move in different directions, if this crest falls on this crest, this particle will go up to 8 meters. So any given particle may go up to plus 8 meters and then minus 8 meters. So this would be plus 8 meter and this would be minus 8 meter. Now whether particle goes to plus 8 or depends on the wave superposition. So if this falls on this, that is if the crest here falls on this crest, this particle will go up to 8 meter. Imagine that at a given point, if the trough and this trough falls, then the particle go up to minus 8 meter, which means this particle can go or oscillate between plus 8 to minus 8 meter. At any point, for example, think it has a displacement of say 5 meters. That would mean that it is this crest falling on this point. If it has a displacement of say minus 3 meter, it means that it is this trough falling on this point. So whether the particle, wherever it is, depends on what falls on which part. But to summarize this mathematically, we can say that the net displacement in this case is equal to the vector sum of individual displacement. That's what is called as the principle of superposition of waves. Now instead of two waves, if you have more number of waves, in that case the form would be y is equal to y1 plus y2 plus y3. In vector form, you can write this as y is equal to vector y1 plus y2 plus vector y3, etc. This is called as principle of superposition of waves. Example is given here. So whatever has been taught has been given example here. Example is a wave coming from this side and this side. This wave has a high amplitude and this has a low amplitude. Look at some point here. For example, look at this point alone. This is a point in focus. So in this point alone, it's not straight here, but then think of that point alone. Or let's draw a straight line from here. Let's take a random point. Let's take a point like this. If you look at this particle's displacement alone, now here the waves are not yet reached. So it's at the mean position. When this comes first and this comes first, it's trying to pull it up. So this part and this part is trying to pull it up. They superimpose when this part and this part falls on it, it will have maximum displacement. As given here, this is a displacement if only this wave was moving, and this would have been the displacement if this alone is moving. But since both are moving together, and keep in mind that only when this maximum and this falls, it goes to maximum height. Example, imagine that this falls on this. It will have some displacement but not maximum. So it will have maximum only if this part falls on this part. And after crossing, they'll go each other. So this particle from here has gone to this position. It's coming down. It's coming down as it will again go to the other extreme position. So this principle is called as principle of superposition of waves.